Hi, I'm Dolphin. I'd like to do a demonstration of the programming technique called test-driven development. And for this session, I will be using a programming kata called FizzBuzz. A kata is just a task or an exercise we can use to practice. And this particular kata, FizzBuzz, is based on an educational game, an elementary mathematics game. And it goes like this. Write a program that prints the numbers from 1 to 100. But for multiples of 3, print fizz instead of the number. And for the multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print FizzBuzz. And the sample output here shows how that works. For 1 and 2, we just output 1 and 2. For 3, we output fizz instead of 3, and so on. But in this case, to simplify it even more and make it more appropriate for this process, we'll just make a function that takes the number as an input and outputs the number or string. To start, we can use this editor window that contains an empty test file. We're using Perl here and the test framework called test more. So the syntax will be specific to Perl, but the process itself is fairly general, so you would be doing pretty much the same thing in a different language. To start, we can just include the test framework, use test more, and even at this early stage we can try running the test file, and it says no subtests run. That just means we haven't written any tests yet. So let's add one test, and let's do it in the simplest possible way. Just OK1, which asserts that 1 is a true value, which it always is in Perl. And we can run it again, and it says now it's still failing, but in a different way. It's giving us a different error message, and the error message is tests were run, but no plan was declared, and done testing was not seen. So just to please the test framework, we're adding done testing at the end. This is sort of a quirk of test more. And let's run it again, and it passes. So now we have not, as you might see, we haven't actually done anything meaningful yet. This is just a dummy test. There's no meaningful testing going on, but we have set up the test framework, and we've seen the basics of how this process works. We go by baby steps, one small step at a time, and I'm always being guided by the test output. So I'm doing what the error message implies that needs to be done. But next, let's start adding a meaningful test. We want to have the function FizzBuzz, which doesn't exist yet, but we're making believe that it exists. So we're writing a test for something that doesn't exist. That's what test first means. And we're saying here, we're asserting that the output or the return value when we input FizzBuzz should, when we input 1, we should get the return value 1. So let's run this, and it fails, and it tells us why it fails. It says undefined subroutine FizzBuzz. So let's just add that. Just the empty subroutine, and I'm adding it in the same file in the test file basically, which is something I wouldn't normally do. It's just for the demonstration, just so you don't get confused by that. Normally I would have a separate file for the code that I'm testing. And let's run it again, and it's still failing, but it's failing for a different reason. We're getting a new error message. It's saying we got an undefined value instead of 1 from the subroutine, the function. So the simplest way to fix that is just to return 1, and then the test passes. And this is, you might say this is cheating. Yes, it is, and the point of doing it this way is to make it as simple as possible, which may not seem to make sense in this context when it's a simple, straightforward piece of code. But if you get more complex situations, it can be really useful because you avoid getting confused, and you can make it simpler for yourself, so you can work by small steps that are easy to understand. And next I would like to do something else. This cycle here is sometimes called the red-green refactor cycle. You may have heard of that, and that's what I've been doing all this time. I make a test that fails, so that's red. Then I add some code to make it pass, that's green. And then I can do a little bit of refactoring if I like. And this time I will be adding or using the subtest feature of test more. I think it's useful because I can add a text description of the test. In this case, 1 is 1. So let's see what happens if we run it again. It still works, so that's a successful refactoring. Now what's next? We could go on by implementing the first part of the functionality we need, which is just to return the input value from the function. But and that could be considered another refactoring step. But for this process, a more suitable thing to do might be to add another test. So we're adding a test for 2. 2 should the input value 2 should return 2, and it's failing since we're only returning 1 at the moment. So we can go back, and now we can implement the functionality I mentioned. Just return the input value, and now it passes again. Next, one more test. So we say 3 is fizz. We know that's it's supposed to work that way, and we run the test again, and fails as expected. It got 3 instead of fizz this time, so we need to add something to do that. And the simplest thing we can do is just to test for, or to check, do an if test for the value 3 and return fizz if it is 3, and then the test passes again. What's next? Well, we know we want to work, we wanted to work with multiples of 3, not just 3. So 6 is an interesting value to try, and it's supposed to return fizz, and it doesn't, because the we're only checking for the single literal value 3, and not for multiples of 3. We can do that if the remainder, when we divide by 3, is 0, then it's a multiple of 3, and then we return fizz. So it passes again. To proceed, let's add one more test. 5 should be buzz, and it fails again. And this time we've learned a little bit from what we've done so far, so we can just do the same thing with 5 that we did with 3. And it passes again. And then now we're missing FizzBuzz. 15 should return FizzBuzz. The test fails. It returns fizz instead of FizzBuzz. So we have to do the same thing with 15. And what happens? Well, it still fails. And let's see why that happens. Well, the thing is that we check for a value that's divisible by 3 here at the beginning, and then it returns fizz, and it does that with 15, since 15 is a multiple of 3. So what we need to do is to move this last line up, and now it passes. That's the end of this part of the demonstration. Let me just add that what I did at the end here, I did it on purpose, but if that kind of thing happens, as it will, you will always make a bug at some point. And the good thing about what we're doing here is that we're getting immediate feedback about the fact that something is wrong. So you can fix mistakes very quickly. You don't have to wait. And in traditional programming that's not test first, you might write a lot of code before you discover that there's a bug, and then you have to search for the bug, and that takes time. Sometimes it can be very time consuming, and this is one of the things that we avoid by using this process. So thank you for watching and listening.